Hey, what's up? It's Jake from Nimbus DevOps, and I am learning Kubernetes. So the next concept we're going to be covering is taints and tolerations. There's some relationship to node affinity here, so I want to make sure we cover that next, but Kubernetes has a lot to say about this in their documentation. I'll cover node affinity separately, but you can see just at a high level that it's a property of pods that attracts them to a set of nodes, whereas taints allow the node to repel a set of pods. So essentially, here's what we're looking at. Taints and tolerations are a lot like labels and selectors. It's like a filter. So if you put a taint on a node, that says, hey, don't schedule any pods that aren't tolerant of this taint. So in this analogy, what you would do is you would put a label on that node, and then the selector would be the scheduler trying to put a pod on a node, and if it doesn't match, then it can't go there. If it does match, it can go there. It doesn't mean that it will go there, but it can go there. The only way I really know right now to put a taint on a node is through an imperative command on the command line. However, you can include tolerations in a pod spec or do it imperatively on the command line, but it's preferred to do it in a pod spec. As you can see here, this is the nomenclature. So you would just put in a tolerations, it's a key, operator, value, and effect, unless you have an operator exists. And you can read about this in the documentation, and I'll provide a link to this documentation in the description of this video. Additionally, once there's a taint placed on a node, there's actual effects that have to take place, and there are three options: no execute, no schedule, and prefer no schedule. I'll start with no execute. So no execute says, hey, if you're a pod and you're already running on this, you need to yeet yourself out of this pod because you're not allowed to stay here unless you have a toleration. Next is no schedule, which tells the scheduler, do not schedule pods on this node unless it has a toleration. The last one is prefer no schedule, which is a soft version of no schedule, where the control plane will try to avoid placing a pod that does not tolerate the taint of the node, but it's not guaranteed. So with a no guarantee thing, it's possible that maybe you don't have enough hardware to support the requirements for deployment. So in the event that you have a taint on a node and a toleration with a pod, maybe that pod is too resource hungry and that node can actually support that. So in that case, it wouldn't actually go to the tainted node. It would go to wherever the scheduler gave the highest score for that other node. So as you can see, there's some more complexity to this where it's not guaranteed that a tainted node will always receive a tolerant pod. Some example use cases include dedicated nodes if you want a set of nodes to exclusively fulfill requirements for a specific set of pods. A big one is nodes with special hardware. So if you have like GPUs and you have certain pod operations that require GPUs, you might want to taint the node that has the GPU and then put the tolerations on the deployment that requires that hardware. The last one's taint-based evictions, and I think an interesting case for this is if you actually have problems with a node. So let's say you have hardware failure, you can actually taint the node and then not add tolerations to the pods, and then they'll kind of fail over, if you will, by way of eviction. So again, at a high level, that's pretty much it. That's what you need to know. If you have any questions, let me know, as always. But if not, my name is Jake with Nimbus DevOps, and I am learning Kubernetes.